Thank you. Okay, so the most common use of the pneumatic road tube is to count the number of axles. Okay, what is an axle? It is a rod which is connecting the wheels on the opposite side of the vehicle. So this rod is basically this one. Okay, so you have the wheel on the right and the left hand side, and the rod which is connecting them and the one which is rotating with them is the axle. So whenever a set of wheels cross the tube, it's an axle. So the main use of pneumatic road tube is to count the number of axles. Okay, this is the data which it gives us directly. Then you can also use the pneumatic road tube for measuring speed as well. Okay, but to measure the speed or to convert the number of axles into number of vehicles, because obviously we are counting vehicles, right? Our aim is to what? Count number of vehicles, flow, volume, everything is terms of number of vehicles. So to convert the number of axles to number of vehicles, or to find out the speed using the axle data count, we need to do a short manual study. Now the keyword here is short manual study, a short manual study. Okay, short is the keyword here. So you cannot complain that why are we using the road tube if we have to do a manual study. The road tube will give you the data for the for an extended period of time, but the manual study is done for a very short period of time so that we can calibrate the data coming from the road tube. Okay, this is just for the purpose of calibration, so we don't need to do it for the full period of the study. Now let me show you an example in which this is being done. Pneumatic road tube data is being calibrated, and then number of vehicles have been found. So in a particular study, pneumatic road tube was used on a highway for 24-hour period. For a 24-hour period, pneumatic road tube was used. In those 24 hours, the road tube recorded 11,250 actuations. Now the word actuation here means number of counts. Okay, whenever we use the term actuation, we mean number of counts. Okay, for any device. So here we are counting number of axles. So actuation means number of axles for the road tube. Okay, basically it means counts, but for road tube we know the count is for the axles. So in a 24-hour period, the pneumatic road tube counted 11,250 axles. Now we need to find out how many vehicles it is equal to. Okay, to find out that, we have done a short manual study on the same location during the same time period. Okay, but it was not the full period of the study, not for 24 hours, maybe for a few minutes. In those few minutes, we recorded the number of vehicles for each category of number of axles. So you can see the table on the slide at the bottom is showing the number of axles on the category for number of axles on the left hand side and the number of vehicles on the right hand side. Okay. Now number of axles can be 2, 3, 4, 5, 6. Okay. And how many vehicles observed for each category, that is in the left hand side column. So for example, how many vehicles observed for 2 axle category? 157. How many vehicles observed for 3 axle category? 55, and so on. Now to convert the number of axles given by road tube to number of vehicles for the full 24-hour period, the quantity I need is number of axles per vehicle, average number of axles per vehicle. Okay, so how to do that? We'll do a small calculation. Okay, so first of all, I need number of vehicles observed in the manual study. Okay, how many vehicles observed in this study? So give me the total number of vehicles observed, which is basically the summation of the left hand side column. How much is it? 303. Okay. Then I need to find out how many axles observed in this manual study. Okay, number of axles. Okay. Now, if you say number of axes is 2 plus 3 plus 4 plus 5 plus 6, you will be wrong completely. Okay. These are just the categories of the axes, categories of the vehicles on the basis of number of axes. Okay. Number of axes observed is how many vehicles crossed with those number of axes. Okay. So, for example, 157 vehicles crossed with 2 axes. So, how many axes crossed in front of me? 2 into 157. Okay. Similarly, 55 vehicles crossed with 3 axes. So how many vehicles, how many axes did these 55 vehicles had? 3 into 55. Okay. So for number of axes observed, okay, I'm not talking about the categories of the number of axes. I'm talking about the number of axes which actually passed in front of me when I was doing this manual study. Okay. So I have to take the number of axes and multiply with the vehicle of that category, the number of vehicles of that category. Okay. So I will do 2 into 157 plus 3 into 55 plus 4 into 50 plus 5 into 33, 2, 3, 4, 5 and 6, which I just realized that I know these numbers by heart, okay, which is weird and pathetic, okay, means that I don't have anything else to do in my life. 892, yes, 892. Okay, now I will calculate average number of axes per vehicle. Okay, which will be the ratio of these two things, right? So 892 axes in 303 vehicles. So how many axes per vehicle? 2.94. Okay, so on average, every vehicle has 2.94 axes per vehicle. Obviously, 2.94 is not a practical number. It's not a realistic number. It's just an average. It is just an average. Okay, so don't say that or don't get confused that how can a vehicle will have 2.94 axes. Obviously, a particular vehicle can have 2 axes or 3 axes or 4 axes, but on average, all vehicles combined, this is the number we get. Okay, so to convert the number of axes into number of vehicles, I will just take the number of axes which was observed by the road tube, which was 11,250, okay, and divide by this number. The number of axes divided by axes per vehicle will give me number of vehicles. How much is it? How much is it? $11,250 divided by 2.94. How much? $3,826. Fine. Yeah, like I said, for the number of vehicles, you can round it off, no problem. Plus minus 1 doesn't make a much difference. Okay, vehicles. So in 24 hours, the approximately 3,826 vehicles should have passed the road tube. Okay, in the same way, you can do the calibration for the speed as well. In that case, you will be recording the distance between the two axes of the vehicle. Okay, and then the sensor will give you the time taken by the two consecutive axes to cross, and then you can find out the average distance between the two axes, and then you can use the time between the two axes to calculate the speed. Okay, so it will be distance upon time. Which distance? Average distance between two axes, and the time which is recorded by the road tube between two consecutive axes. Okay, so you can have a speed of each vehicle. Okay, any questions? Any confusion? Is it clear? Okay. Now in this particular slide, you can see 3 different settings of road tube for 3 different purposes. So in figure 1, the top one, you see one road tube which is laid across the entire roadway, both directions. So obviously this road tube will give you the data for both directions combined. Okay. Then you see in figure 2, we are using 2 road tubes, one for each direction. So obviously data from each road tube will be for each direction, right? So in this case, I don't want the combined data. I want separate data for each direction. Okay, so I will use 2 road tubes. Now figure 3 is something which is interesting because now I'm trying to collect data for each lane. Okay, so you can see each direction has 3 lanes, and you can see 3 road tubes here as well. But it doesn't mean that each road tube is recording the data for each lane. Why? Because I need to put the sensor on the side of the road, right? I need to put the sensor on the side of the road. So what will happen to the middle lane in that case? Okay, if I use each road tube for each lane, then where would I put the sensor? The road tube will be across the middle lane and the sensor will be somewhere here, right? And this is blocking the right hand side lane. Okay, so this arrangement cannot work. So we go for this arrangement. So in this arrangement, we have 3 sensors. Let's say A and B and C. Okay, so sensor A or road tube A is directly recording the data from right hand side lane. No problem, right? It's very obvious. Whatever the number you get from sensor A or road tube A is for lane 1, or let's say the right hand side lane. Now the data from B is for right hand side lane and the middle lane. Okay, middle plus right hand side lane. So if you want the data for the middle lane only, then you will do B minus A, right? Because A is only for the right hand side lane and B is right plus middle. So when you do B minus A, then you will get the data for the middle lane, and obviously it must have been taken on the same day, on the same time, and so on. Then what about the third lane? If I want the data from the third lane, the left hand side lane, what should I do? Tell me. If I want the data from the third lane, what should I do? C minus B. Okay. No, C minus B plus A will be wrong because B already has the data from A. B already has the data from A. So it will be only C minus B. Only C minus B. Okay. If you do C minus B plus A, you are subtracting the right hand side lane twice. Okay. One in the count of B and then again from the count of A. Okay. So it will be C minus B. Simple. C minus B. Because B already has the middle and the right lane. Okay. So C minus B. So if you want the data for each lane, then you have to employ multiple tubes, but you have to do some post processing as well. Simple post processing, subtracting numbers will not be difficult. Then we go for, then we will discuss automated studies. The prime difference between semi-automated and automated studies is the use of the detector, the type of detector. In semi-automated studies, we said we use portable detectors, portable devices like a road tube. Okay, so once the data collection is finished, you will take the sensor, roll up the tube, and take it with you to the office. But permanent, in automated studies, we use permanent detectors. Permanent detectors. So once a detector is installed on the site, the data must be extracted from the detector from using some transmission channel without disturbing the detector itself. The detector should not be disturbed from its position. Okay, while you are collecting the data. Okay, so the data collection and like the data transmission is happening in real time. Okay, like for semi-automated, you are doing it in 2 steps, right? Collection of the data and then extraction of the data somewhere in the office. But here it has to be done real time. Okay. So these permanent detectors are installed on the side of the road, like in the form of sensor or detector. Okay, like I've given the example earlier, the checkposts that we have or the gates of the university or so on. These are permanent detectors, but they are installed on the side. Then you can have installed under the surface of the road as well. or you can have cameras which are overhead. Okay, so traffic cameras are what? Permanent detectors. So when the violation is caught, the traffic police doesn't have to come to the camera and take the camera with them to know who has violated the speed limit or the signal. The camera directly transmits the data to the traffic directorate. Okay, how is it done? Very easy. You go to the market, you ask for any CCTV camera. These CCTV cameras come with IP address. Okay, so same technology is used for traffic cameras as well. You can access them through IP address from anywhere. Okay, some of them have Wi-Fi capability as well. Some of them have the option to attach with a wire as well. Okay, so you can attach them with a wire, and the other end of the wire can be attached to another computer or any other system, and the data is extracted. You attach your system to the wire, extract the data, and then so the detector in its place, you are not disturbing it, you are not removing it, just you are attaching and detaching with the wire of the detector, and that's it. So these detectors, they are expensive than portable detectors. They need more maintenance as well, and almost all of them have multiple functions. There are multiple functions. So once you install them, you can collect volume, speed, density, many things. Okay, and they have the capability, like I said earlier, to transmit data real time. So like the traffic cameras, they transmit the data real time to the traffic directorate. Okay, so they have the so they can transmit the camera the data to the traffic directorate as well as any traffic control device. For example, a signal. So many detectors are directly connected with the signals or traffic control devices such as a signboard or something, and the data is recorded and it is transmitted to the device, and the functioning of the device can change according to the data of the detector. Now, if you need more information about the traffic detectors, I have mentioned a reference here. It has complete details about different types of detectors and their technology. Obviously, it's not our field. As civil engineers, it's not our field. Our field is mainly traffic management. Okay, but if you are interested in electronics and the mechanics of the detectors, you can go through this book. It is available free online. Okay. Some of the technologies used in the detectors are mentioned here, the permanent detectors. We have sound technology, also known as acoustic. So the noise produced by the vehicles is detected and counted. We have opacity. Opacity means a technology in which you are capturing the data from the image or the video. Okay. So you take the video, then you upload it to a software, and the software will detect the movement of the cars from the video. Same thing can be done with the images as well. So you have an image, a satellite image or something, and the number of vehicles can be detected and counted from the image. Okay, drone image, satellite image, or an infrared image as well. Okay. So infrared, basically, then you have you are not looking at a simple color image. You are basically looking at the infrared image of the road. Okay. Then we have geomagnetic detectors, which work on magnetic fields. Okay, so there are magnetic sensors and magnetometers attached, or they are provided in this system, and you create a magnetic field around the road, and a small magnetic field, nothing to disturb the flow. And whenever a car passes, the magnetic field is disturbed, and the count is recorded. Or you can use other transmitted energies as well. So in the fourth type here, reflection of transmitted energy, you have a transmitter and a receiver. Transmitter is on one side of the road, receiver on the other side of the road. The transmitter will keep on constantly sending the signals in the form of energy towards the sensor, and these signals can be in the form of radar, laser radar, ultrasonic waves, or microwave rays. And whenever the signals are disturbed with the movement of the vehicle, the count is taken. Okay, and then we have electromagnetic induction detectors, which are also known as loop detectors, and they are very commonly used on intersections in Bahrain as well as around the world. So if you want to see a loop detector, if you are coming close to a signal, you will see, so if this is a signal, let's say this is the stop line. Before the stop line, you will see two rectangular patches on the pavement. Okay, so these patches are basically showing the loop detectors. So loop detector is a set of two detectors which are attached to each other, like they are communicating with each other. So whenever a car crosses the first detector, it detects it, and the same car reaches the second detector, it will also record it. Okay, so you can know the speed and how many cars crossed each detector and so on and so forth. Okay, so this is what we call as a loop detector. It's a set. Okay, it is very commonly used on signals to know the speed of the cars, how they are approaching, how far they are behind the signal, and so on. So it's very commonly used. Then we have, we will discuss more about VIP. I mentioned it earlier as well, but we will discuss in more detail now. VIP means what? Who can tell me the meaning of VIP? VIP stands for what? VIP. VIP, very easy. You must be thinking I have a trick up my sleeve, right? It's very easy. Why I'm asking for this? It's very easy. That's why I'm asking. Very important person, right, Mariam? Very important person. So Mariam, Vasan, you are very important persons, right? Everybody in the class is a very important person for me, at least. So, but for this case, for the case of detectors, it doesn't mean very important person. It means video image processing. Video image processing. So Jafar, you were Googling it? Huh? Or Googling it or looking into the book? Anyways, well done. Well done. People who said very important person, they are also right. Jafar is also right because he is agreeing with me. Video image processing, VIP. Here means video image processing. But if you go to the ministry, if you are in a government department, that means very important person. Okay, don't forget that. Don't say that VIP always means a very important video image processing because I said so. I am nothing. If you go in the government department, VIP means very important person. Okay. For the case of traffic engineering, video image processing. Video image processing. It comes in the exam, then video image processing. Obviously, it will not come in this exam. So video image processing, you install cameras on the road. The cameras will record the video of traffic flow. Later on, the video will be uploaded to a traffic software or a general purpose software like MATLAB. MATLAB also has tools by which it can extract the movement of vehicles from a video. Okay. These cameras are very commonly used on intersections. This technology is very commonly used on intersections. Okay, because otherwise you have to do it manually. And another good thing about an intersection is the placement of the camera. So for example, you have a signal. Okay, this is the polar signal, and then the signal lights are installed like this. You have the three lights here. Along these lights, you can also hang your camera as well. So that camera will be looking at the road front on from the top. Okay, so top front view. Okay, and then you can turn or focus the camera towards a particular lane, or you can cover all the lanes of the road in one video. Okay, so the pole of the camera, they call it the mast arm, on which you will see the, so this is the mast arm. Okay, where you have the lights, traffic lights. So on our signalized intersection, we have a very good opportunity to place a camera in an appropriate position with the mast arm of the signal. Okay, so this is why it is commonly used on intersections. A VIP system consists of three things: a camera, a microprocessor, and a software. Camera, microprocessor, and a software. Okay, camera to record the video. Now we are talking about traffic cameras. Okay, cameras which are used for traffic data collection exclusively. Okay, so these are special cameras. So they have slightly advanced microprocessors in them. So you can calibrate the video of a traffic camera, okay, to give you to extract or to detect the presence of a vehicle directly from the video. Okay, so other microprocessors which are with the camera, they just record the video, but a microprocessor with a traffic camera records the video and also detects the presence of a vehicle if it is calibrated. Okay, so you have to do some calibration again for a few seconds, for a few minutes. Okay, so you come and you have the video in front of you. In the video, you mark wherever you see the vehicle, wherever you see a bicycle, you will mark it as bicycle, will mark it as a pedestrian, and so on and so forth, so that the camera later on can easily detect, the processor can later on easily detect from the background image which one is a car, which one is a bicycle, which is a pedestrian. Okay, and obviously you have the background of the pavement, and you have the stationary objects such as light poles and signals and roundabouts. So if you don't calibrate the microprocessor, then you will have a lot of errors in your data. So you need to calibrate the microprocessor. And again, I'm talking about the microprocessor of a traffic camera, which can be calibrated to detect vehicles from the video. And then later on, like I said, you upload the video to a software. This is the third part of the system, and the software can convert the detections into number of vehicles and speed and so on. So software will give you the numeric data. Okay. So a vehicle, when it is moving through the video, it is a set of pixels, a compressed set of pixels. So the calibration is done. So the whenever a compressed set of pixels of that size moves through the video, the processor can detect it. This calibration must be done in different conditions, because the conditions of the road will change according to weather, according to light, according to time of the day. So the calibration must be done in different timings. Okay, so that you have the calibration in all sorts of conditions. The detector can detect accurately in all sets of conditions. Okay, now VIP technology, video image processing technology, is becoming popular day by day, and it is estimated that in near future you may see it everywhere. Okay, we see it often. Okay, even now we see it very often, and now this technology is equipped with the communication with the traffic control device directly. So you have a traffic camera which is recording traffic data, and the data from the traffic camera can directly influence the working of a traffic signal, for example, or the speed limit, or a variable message sign. Okay, I have a video about that. Okay, let me show you the video. I think it is open. Yeah. So in this video, you will see a camera, a VIP system attached with a traffic signal system. Okay, so this is the main screen, which you can see. Then you have on the right hand side some buttons for different cases. So each case refers to a different set of traffic signal timings, a different set of traffic signal timings. Okay, so the sensors are attached here. Okay, on the road. Normal case means normal traffic which is coming from all directions. So whenever you have the normal case, you click on the case 1 button, and the signal timing will be changed according to the timings which you have according to case 1. Okay, but it will be as per the traffic flow. Okay, it will be as per the traffic flow. So you see the signal on the top side was green. Now the signal on the left hand side is green, and you have a timer attached with them. Okay, and the sensors are also recording how many vehicles are waiting on the other sides. Okay, then we have case 2, which is for the skip. So whenever you see that the traffic from a particular direction is not coming at all, then you can program the signal to skip a phase completely. So it will not turn green for a particular direction at all. It will keep on giving green to the other sides. Okay, and this is all being done on the basis of data coming from the detectors. And then we have case 3, which is for extended time. So if you see, or the detector realizes or communicates that traffic from a particular side is heavier than the other sides, then it will give more green time and yellow time to that side instead of the other sides. Okay. And then we have case 4 where no car is around, okay, from on other sides. So signal will be green only on one side. It will remain green until you don't have any other car, until you have a car from any other side. Okay, so you can see the signal is green and the counter on the signal is stopped. Okay, so it will remain green until the car comes from any other side, and when the car comes from the other side, then the counter will start to move. So the people from that side know that the signal is about to turn yellow and green, yellow and red for them. So counter stopped means you have unlimited green. You can just keep on moving. Okay, so and then the last thing is showing the contour. So you have the show contour button on the right hand side again, and the contour basically size and location of the vehicle. Okay, the size and location of a particular vehicle. Okay, the vehicle which is moving through the intersection, what is its size and in what pattern it is moving. Okay, so it gives you like a very focused view for a specific vehicle. Okay, the vehicle which is at the front. Okay, what is its size and like how will it move from one side to the other. Okay, so you will not see anything else. Okay, so I will not I'll stop here now. Okay, if you have any questions, any queries, anything you want to say, any suggestions, please go ahead. Okay, in that case, all the best. I will see you on Tuesday for the exam. I'll not take the classes on Tuesday, so I'll just see you for the exam. All the best for the exams. If you have any questions, please send it to me. I'll try to respond as soon as possible. And thanks for listening. Thanks for participating. And all the best for the exam. Okay. Assalamu alaikum. Have a nice day. You are all welcome. Thank you.